Okay, so as in the last video we have discussed about the capacitance of a capacitor, which was the constant, right? That was the ability of the capacitor to store the charges on it, right? So we were known that the charge which are stored on the plate of the capacitor will be directly proportional to the potential difference provided to it, right? When we remove this proportionality sign, we know that whenever we'll be removing the proportionality sign, we'll be having is equal to sign with that constant, right? So Q is equal to CV. So is equal to and C just we got by removing the proportionality sign. So we know that voltage is multiplying with it with the C here. When we get this V there, it would be divided, right? So C is equal to Q over V. Here we got that C is nothing but C is the constant which was known as the capacitance of a capacitor, right? So capacitance was nothing but it was the ability of a capacitor to store the charges on it, right? Then we have discussed about the dependencies of the capacitance. Capacitance depends on the three things. It depends on the distance between the plates, right? The smaller the distance would be there between the two plates, the larger the capacitance will be. We will be discussing about each and everything. If this capacitance is directly proportional to the distance or inversely proportional to the distance, we'll be discussing that everything in our coming videos, right? Here we have just discussed that capacitance depends on three things: the distance between the plates, secondly it depends upon the area of the plates, right? Thirdly, it depends upon the material of the medium, right? Then we also discussed that it does not depend on one thing, and that was the thickness of the plate. No matter how thick the plates are, the capacitance would not be affected, since capacitance does not depend on the thickness of the plate, right? Here because of this, you know what equation, C is equal to Q upon V, we have got our another definition for the capacitance as well. Capacitance is nothing but it is the ratio of the charge and the potential difference provided to it. Capacitance is nothing but it is a charge stored on the plate, and the potential difference across the conductor is what we call the capacitance of a capacitor, right? So we have got our two definitions. Today we are going to take out the unit of this constant capacitance, right, which is the ability of a capacitor to store the charges on it, right? So C is equal to Q over V. Wait, now I'm continuing here, right? C, wait, let me drive this equation again. We know that the charges stored on the plate of the capacitor is directly proportional to the potential difference provided to it, right? When we remove this proportionality sign, we get is equal to CV. Here C is the constant, so C is equal to Q over V. C is the constant which is known as capacitance of a capacitor. It is the ability of a capacitor to store the charges on it, or it is the ratio of the charge which are stored on the plate of the capacitor and you know what, the voltage or the potential difference across the conductor, right? This is what we call the capacitance of a capacitor, C. So we know that the SI unit of charge is what? It is coulomb, right? It is coulomb. And the unit of potential difference is voltage, or you can say volt, right? So coulomb per volt is the unit of C, which is the capacitance of a capacitor, or you can say coulomb per volt is equivalent to farad, is equivalent to farad. So if there is an MCQ coming that what farad is equal to, farad is equivalent to coulomb per unit volt, or coulomb per unit volt is equivalent to farad. Okay, then they can also ask what is 1 farad equal to, right? What is 1 farad equal to? So 1 farad would be equal to 1 coulomb of charge, 1 coulomb of charge per unit 1 volt across the conductor, right? So this is nothing but if 1 coulomb of charge given to the plates of the capacitor and 1 volt provided across the conductor, then its capacitance would be 1 farad, right? So this is very important in terms of MCQs. Let me write what 1 farad is equal to. MCQ, right? This I'm gonna highlight then with another highlighter, right? So this is very important point. If 1 coulomb, if 1 coulomb charge given to the given to the plates of the capacitor of the capacitor and 1 volt provided across the conductor provided across the conductor, then its capacitance would be 1 farad. Capacitance would be 1 farad. All right, that would be 1 farad. 1 coulomb per volt, 1 coulomb per 1 volt would be equal to 1 farad, right? So let me just highlight this. If 1 coulomb of charge given to the plates of the capacitor and 1 volt provided across the conductor, then its capacitance would be 1 farad. 1 coulomb per 1 volt would be equivalent to 1 farad. Alright, now let's go to discuss some other units for the farad, right? Here again, this is very important in terms of MCQs, right? Other units. Other units, right? So they can ask you for 1 microfarad. We know that this is the sign of micro. Alright, we have already learned about the units, we have already learned about the prefixes, right? Deci, centi, milli, micro, nano, pico, and if you can go top of the it, so you get deca, hecta, kilo, mega, giga, tera, right? These are some prefixes which you need to learn. So 1 microfarad is equal to 10 power minus 6 farad, right? 10 power minus 6 farad. Then they can say 1 nanofarad is equal to what? So that is equal to 10 power minus 9 farad, right? 1 microfarad is equal to 10 power minus 6 farad. 1 nanofarad is equal to 10 power minus 9 farad. Then they can say 1 picofarad is equal to how many farad? So that would be equal to minus 12 farad, right? So they can ask, this is very important and this is very, common too. 1 microfarad is equal to what? So we know that 1 micro is equal to 10 power minus 6 into 1 micro is equal to 10 power minus 6. Bases are same, so power would be added. So 10 power minus 6 is minus 12 farad, right? So 1 microfarad is equal to 10 power minus 12 farad, which is called 1 picofarad. 1 picofarad. Alright. So if they are asking you 1 microfarad is equal to, that would be 10 power minus 12 farad. And if they are asking 1 microfarad is called, then you need to give them the answer of 1 picofarad. These were some very important units in terms of prefixes. Alright, we have a lot of prefixes that we have already learned or covered in our level 9 syllabus, right? Here you just need to remember this SI unit of capacitance, which is farad, alright, and that is equivalent to coulomb per volt. this is what we have discussed in today's class. We have basically discussed the unit of the capacitance of the capacitor, right, which is the ability of the capacitor to store the charges on it.